everyone. So this is going to be the first of 3 videos that we're going to spend talking about linear functions. So this video is going to be basically just a kind of a review of the essentials that you need to know about graphing linear functions. So we're going to talk about slope and y-intercepts, and basically if you're given a function, how to sketch its graph, or if you're given a graph, how to write an equation for that graph. So for a lot of you, I think that this will be a review. This is stuff that you are technically supposed to know before taking this class. So, if you start watching this and you feel like, I think I'm pretty confident about all the material in this, you can feel free to skip this video. The reason I'm including it, even though it's technically stuff you're supposed to know before this class, is first of all, there's always, some students know this stuff coming in, some don't. Also, just because it's so important, like it's so essential that you understand how linear functions work, that, I think everyone can probably benefit from reviewing it. So the next couple of videos after this are going to focus on, the next one will be about like word problems and how to understand the significance of slope and y-intercept in the context of a word problem. And then the next video after that will be talking about a different format of writing the equation of a line called point slope form. Okay, so let's get right into it. So we talked a little bit about linear functions, like probably a while back, I think in section like 2.1 or 2.2. And so what we learned is that a linear function is a function that can be written as f of x is equal to mx plus b. So f of x is equal to mx plus b. And you might have seen it written as, y is equal to mx plus b, and that's fine, right? So one thing that I'm not sure if I've emphasized yet in this class, but that's good to know, is that having f of x equal to a function is essentially the same as y is equal to a function, right? Because remember that when we're graphing functions, the outputs, the f of x values, those are the y values. So either way of writing it is fine. For this video, for the most part, I'm going to use function notation just because that's really, it kind of fits better with talking about these as functions. Okay, so f of x is equal to mx plus b. So what do these different, components of this equation mean? Well, the m, this number here, this tells you the slope of the line, the linear function. So it's called a linear function because its graph is a line. We'll talk about exactly what slope means in a moment, but this number m is going to refer to the slope of that line. And then b is what's called the y-intercept. And so the y-intercept is the place where the graph, the y-coordinate of the point where the graph crosses the y-axis. So again, we'll see that in some examples in a little bit. Okay, so let's start by talking about slope, how you calculate slope. So you can think of slope as basically a way of measuring how steep a line is, as well as whether it's increasing or decreasing. So whether it's kind of going up from left to right or down from left to right, and then also how steep it is. So specifically, so let's say you have some kind of a linear function. How do you find the slope of that linear function? Well, you can take any 2 points on your graph, label one of them as x1, y1, so x coordinate, y coordinate, and the other one as x2, y2. Okay, so what is the slope? Well, the slope is basically a measurement of comparing the vertical change and the horizontal change from one point to another. So slope can be, I'm going to kind of write this actually 3 different ways. So slope, one way of talking about it is that it's, if you look at these 2 points, it's the rise over the run. So what do I mean by that? Rise basically means how far you have to go up or down vertically to get to the other point. So that would be the rise. So that's what I just kind of drew in this dotted line in purple. And then run refers to the horizontal distance. So you're basically measuring vertically and horizontally how far do you have to go from one point to the other. So what's like another way of saying this? Well, you could also describe this in words as being the change in your y values over the change in your x values, right? Because if you think about it, that's really what the rise and run are referring to. They're referring to how far do you have to go vertically, that's the change in your y values, over how far do you have to go horizontally, that's the change in your x values. And so that brings us to the last way that you can write this. So change in y, how would you actually calculate that change in your y values? Well, you would subtract the two y values, right? So you could find this purple distance by doing y2 minus y1, and you could find this horizontal distance by doing x2 minus x1. And so the final way that we can write slope is y2 minus y1 over x2 minus x1. So any of these ways of thinking of it are fine. It really kind of depends on what you're doing to kind of choose which way is the best way. Okay, so let's do a quick example just to kind of make sure you know how this works. So we're just going to look at this graph and we're going to find the slope of this graph. So find the slope of the line that we've graphed. Okay, so basically you can pick any 2 points on the graph that you want. It doesn't matter which 2 points you pick because the slope is always going to be the same for the entire line. So generally you just want to pick 2 points that look like friendly. So I would maybe pick this point, the point 1, 1, and this point here, which is the point 2, 4. And so the slope is going to be that vertical change over the horizontal change. And so we can, either count boxes or subtract, but we can see that that vertical change is going to be 3. So how could you get that using these numbers? Well, you could subtract the y coordinates, right? That's how you could, without counting, figure out what that slope or what that vertical change was going to be. And then the horizontal part, again, you can either look at the graph and just kind of count, or you can subtract the x coordinates. So the x coordinates would be 2 minus 1. And so this simplifies to being 3 over 1. And so you can just say that the slope is 3. So one thing I just want to mention is that sorry, I forgot for a second what I was going to say. So the order. So this is something we actually talked about in the average rate of change video, and we'll get more into this in the next video, but this might feel similar to the average rate of change, and it is, right? Because the average rate of change was actually finding the slope of what we called the secant line. So really the average rate of change formula is the same as the slope formula. It's just that you use it a little differently. But what I just wanted to say here is that it doesn't matter which order you subtract the coordinates in, as long as you're consistent. So if instead you had done 1 minus 4 over 1 minus 2, initially it's going to look different because you would get negative 3 over negative 1, but then that still simplifies to being 3. So it doesn't matter what order you do it. What would be wrong is if you switched only part of the order. So let's say you did 4 minus 1 over 1 minus 2. Well, then that would give you negative 3, which would be incorrect. So just make sure you're consistent. Whichever you're putting first, just put it first in both of them, in both the numerator and denominator. So I just want to briefly mention, just now I said, okay, like what if you had done this wrong and you did 4 minus 1 over 1 minus 2, you would get negative 3. So how could you immediately tell that negative 3 was the wrong slope? Well, you really should be able to tell by looking at a graph whether its slope is negative or positive. That's something that you want to be able to quickly visually check so that you don't, make a mistake and not be able to catch it. So what does a graph of a line look like if it has a positive slope? Well, it basically looks like it's increasing. It's going up from left to right. So any function, any linear function with a positive slope is going to look like this, something like this. It's going to be increasing from left or going up from left to right. So it's an increasing function, right? We learned that in a video a little bit ago, we learned that if a function is going up from left to right, it's increasing. And now if you have a line that has a negative slope, well, that means that it's going to be going down from left to right. So it's just, I think I've seen a lot of students who, otherwise are doing great on things, mess up finding the slope, where if you just quickly looked at the picture and asked yourself, is this increasing or decreasing, you would be able to catch the error. So just make sure that you're kind of, when you're calculating slope, that it makes sense for the picture that you're seeing. Okay, I just want to show you one other thing kind of in that same vein. So I have here just graphed a line. And so if you look here, I typed in f of x is equal to mx plus 3. So we'll get more into this in a moment, but remember that this number that you're adding, that is the y-intercept. So that's why the graph crosses through this point 0, 3. But I put in m here because I want to show you what this line looks like for different values of m. So we're going to change the slope and kind of see how things change. So I think it's a really good idea to be able to recognize what a line looks like with a slope of 1. So that's what I have right now. It says m is equal to 1. So when a line has a slope of 1, it kind of perfectly goes evenly in the x and y direction, right? It basically forms a 45-degree angle with the horizontal. It goes perfectly up 1 over 1, up 1 over 1, up 1 over 1, etc. So what happens if I increase the slope? Well, it gets steeper, right? So the bigger the slope, the steeper the graph is going to be. So when you have a slope that is bigger than 1, it's going to look steep. It's going to look like it's steeper than 45 degrees. Now, if I bring the slope less than 1, but still positive, well, now it's going to look like it's less steep than 45 degrees, right? It's kind of not going up as quickly. And then if I bring the slope to negative, so let me first go to -1. So -1, we can see it's decreasing, but we see it still has that like 45-degree angle shape. And then the more negative I bring it, the steeper it's going to get. So it's getting steeper and steeper, but now it's decreasing. And then if I bring it to being something like closer to 0, like -0.5, for example, well, then that's going to look less steep than -1. So I think it's just a really good idea just to, again, be able to kind of like check in that your answers make sense, just to have some vague idea of what lines with different slopes are going to look like. Okay, so the next thing we're going to talk about is kind of putting this all together with the y-intercept. So I want to do a couple of examples. We're going to sketch a graph given its equation, and then we're going to do the opposite. We're going to take an equation and write a function for it. So we're going to sketch the graph of the linear function f of x is equal to -3/4 x plus 2. Okay, so first of all, let's kind of identify what these different things are telling us. So this -3/4, that's going to tell us the slope. And then this 2 here, that's the y-intercept. And specifically, so the y-intercept being 2 means that the graph is going to pass through the point 0, 2, right? Because the y-intercept is where the graph crosses the y-axis. And if you think about it, the x-coordinate of any point on the y-axis is 0. So let's go ahead and put that point on to start with. And that's usually, I think, the best way to start to graph a line is to plot the y-intercept. Okay, so now we just need to plot like one more point. So one thing that's nice about graphing lines is you actually only need 2 points. Sometimes it's nice to plot like one more just to kind of check yourself, but as long as you have 2, if you have, a straight edge, like a ruler or something, if you just extend it, you'll get the correct line. So we just want to pick one more point. And so we want to use the slope of -3/4. So if the slope is -3/4, you can kind of write this 2 different ways. You can put the negative sign either in the numerator or the denominator. So I'm going to put it in the numerator. I think that's generally the easier way to think about it. So remember that -3 is going to be our change in y. And I'm going to actually write that as, well, actually rise is kind of a weird word because we'll see that it's actually going down. So I'll say change in y. And then 4 is supposed to be our change in x. And so what that means is that from this point that we've already graphed, we want to go down 3. So 1, 2, 3, down 3. And then we want to go over 4 in the positive direction. So 1, 2, 3, 4. So this is going to be our other point. So from here, we can just connect the dots and that's our line. If you wanted to do one more point, let's say you wanted to do another point over here somewhere. Well, then you would actually want to go up 3 and to the left 4, right? Just to kind of continue this same shape. So up 3 and to the left 4 would give us this. And so now we can connect the dots. And that's it. But like I said, you only need 2 points. The reason I did 3 is because, I'm drawing on a computer screen and I can't really use like a ruler or something. If you're drawing this by hand, you can totally just do 2 points, connect them, and use a ruler to extend, and then that will give you the correct line. Okay, so let's do another example, but now kind of going the other way. So in this case, we want to write the equation of the linear function that we have graphed here. So now we're kind of working backwards. So what do we need? What information do we need in order to write the equation? We need to know what the slope is and what the y-intercept is. So maybe let's start with the y-intercept because that's kind of the easier one to just grab quickly. So the y-intercept, it looks like the graph crosses the y-axis at -4. So the y-intercept is going to be, I like to write the y-intercept as an ordered pair, so 0, -4, or you could just say the y-intercept is 4, or sorry, -4. So now we need to find the slope. So how do we find the slope? Well, just pick another nice looking point on your graph, a place where you can actually tell that the graph definitely goes through that point. And then you can either count the boxes or actually just subtract the coordinates. In this case, I think it's easier to just count boxes, right? So if we want to figure out what the vertical change is, we can just count how far we go up from the first point to the second point, and it looks like that is a rise of 3. So let me write this down. So our slope is going to be rise over run. That's kind of the way we're going to think about it. Although, like I said, you could definitely just subtract the points and do it that way as well. So how much did we go up? We went up by 3. And then what is the horizontal change? Well, we go over by 2. Let me actually put that 2 somewhere else because that looks a little misleading. Okay, so we have 3 over 2. And one thing I think is a really good check-in to do if you're given a graph and you're coming up with the slope, especially if you're doing rise over run, sometimes you can kind of mix up the sign and end up with something that should be positive or is flipped positive or negative. And so it's always a good idea just to double check that whatever answer you got looks like it makes sense for the graph. And in this case, our graph is going up from left to right, right? So we can tell that 3/2 seems appropriate. And additionally, 3/2 is a little bit bigger than 1, right? It's like 1.5. And so we can see that this graph is a little bit steeper than a 45-degree angle. So it all kind of lines up. Okay, so now we're ready to put this together. So our function is going to be in the form f of x is equal to the slope times x, so 3/2 x, and then plus b, which is our y-intercept, and so our y-intercept was -4, and so that is our equation. Okay, I want to talk a little bit about why is it that m gives you the slope and then b gives you the y-intercept. So that's what we're going to do now just for a moment. We're just going to look at like one example. And then we will also talk about horizontal and vertical lines, and that will be the last thing of today. So y is m the slope, and y is b the y-intercept. I didn't spell that right, intercept. So I think that the easiest way to kind of test this out is by making a table. So let's say, for example, we have the function f of x is equal to 2x plus 3. So I want to be clear here. I don't think in general it's a good idea to make a table every time you graph a linear function. It's just going to slow you down. Really, like I said, you only need 2 points to sketch a graph. So really, the fastest way to sketch a function, a linear function, is to look at the slope, look at the y-intercept, plot the y-intercept, plot another point, connect them, that's it. Plotting, making a table is kind of a fallback plan if you like forget, what you're doing with the linear function. But the reason that I'm making a table here is because I think it will illustrate why it is that m gives you the slope and b gives you the y-intercept. So let's make a table just with a few values. We're going to do 0, 1, 2, and 3. And I want to kind of calculate for each of these. I'm going to write out like the long way how we calculate our answer, and then we'll write the answer for f of x. Okay, so let's say we're plugging in 0. So f of 0 would be 2 times 0 plus 3. And so that would give us an answer of 3. So when x is 0, the y-coordinate is going to be 3. Then we can plug in 1, so that would be 2 times 1 plus 3, and that is equal to 5. If we plug in 2, we have 2 times 2 plus 3, and that is equal to 7. And if we plug in 3, we have 2 times 3 plus 3, and that is equal to 9. Okay, so remember that slope is the change in the y over the change in the x. So because notice that each of these x values is only going up by 1, that means if we just look at how much the y values are going up, that will tell us the slope, right? Because the change in x from one point to the next here is just 1. And so notice that each time we go from one point to the next, we're always going up by 2. And so 2 is the slope, positive 2. So why, where is that coming from? Well, notice that every time we plug in a different value, we're multiplying 2 by, we're kind of adding one more additional copy of 2, right? So for example, when we plug in 1, we have 2 times 1, which is 4, or sorry, 2 times 1, which is 2, plus 3 is 5. Then we have 2 times 2, which is 4, plus 3 is 7. Then we have 2 times 3, which is 6. So notice that every time you plug in a bigger value for x, because you're multiplying it by 2, that basically means you're just adding one more copy of 2, right? It's like you have 1 copy of 2, then you have 2 copies of 2, then you have 3 copies of 2. If you plug in 4, you'd have 4 copies of 2. And so because you're always adding 3, the adding 3 part isn't really going to influence how much it's going up by. It's this 2 that is going to influence how much it goes up by every time you plug in a larger number. So what about the y-intercept? So why is it that 3 ends up being the y-intercept? Well, when you plug in 0, so let's look at the picture for a second. Y-intercepts always happen when x is equal to 0, right? Because that's where the graph crosses the y-axis, is when x is equal to 0. And so if you plug in x is equal to 0 into a function, the first part just is going to go away, right? Like this part is just going to equal 0 when you plug in 0. And so all that will be left is this number here. And so basically, because when you plug in 0, you're just left with whatever that plus b is, that's why your y-intercept is b. So hopefully that gives you a little bit of an intuition for why the slope and the y-intercept work the way they do. So the last thing I want to talk about here is horizontal and vertical lines, which are a little bit different than the other types of lines that we've talked about in this video, but I figure they're worth mentioning while we're on the topic of lines. So we talked about horizontal lines actually in one of our videos a while back. So horizontal lines are actually the same as what's called a constant function. So a horizontal line can be written in the form f of x is equal to some number b. And so these are what are called a constant function. So we talked about this in another video, and we said that basically they're called constant functions because, or sorry, I said the word video and then I wrote it constant function. They're called constant functions because they're always the same value. You know, if you look at a linear function that goes up or down, its value changes depending what x value you plug in. But a horizontal line is a constant function because no matter what x value you plug in, the y value is always the same. It's constantly the same value. And so a constant function, just to give an example, could be something like f of x is equal to -3. So what would f of x is equal to -3 look like? It would just be a horizontal line through a height of -3. You can also write a horizontal line if you don't want to use function notation. You can also write it as, y is equal to whatever. So this could be y is equal to -3. And I think sometimes students get a little mixed up. You might think that if you're talking about y, it should be a vertical line. But really what this means, if you're saying y is equal to -3, that means that y is always equal to -3. And if you think about what that looks like graphically, it's a horizontal line, right? Because you're basically saying it's always the same height, and always the same height means that you get a horizontal line. Okay, what about vertical lines? Well, if the way that you write a vertical line is, horizontal line is, y is equal to a number. Well, vertical lines you write in the form x is equal to some number. So we'll see that you actually cannot write a vertical line using function notation. So let me actually start by just sketching an example, and then we'll talk about, why is it that, that you can't use function notation. So for example, let's say you had the vertical line x is equal to 2. So what would that look like? That would be a vertical line at a x value of 2. And kind of like by the same reasoning as this one, y is equal to -3 means that you're always at a y value of -3 regardless of what the x coordinate is. And so similarly here, you're saying x is always equal to 2 regardless of what the y coordinate is. So why can't we write this in function notation? Well, because it's not a function. So how do we know it's not a function? Well, remember we have this thing called the vertical line test, which says that if you can sketch a vertical line that crosses your graph more than once, it's not a function. And I could literally just draw a vertical line on top of this one and it would cross the graph everywhere. So it's just like it fails the vertical line test the worst that anything could ever fail the vertical line test. So this is not a function. Another way of thinking about it is that, if you were to try to make a table for this, so let's say you tried to make a table and, think about what would be the different x and y coordinates. Well, the x coordinate would always be 2, right? You'd have and maybe I'll even write this as f of x just to show you why this doesn't work. So you would say x is equal to 2, f of x is equal to 0, x is equal to 2, f of x is equal to 1, x is equal to 2, f of x is equal to 2. And so there's way too many different outputs with the same input, right? If you were to try to evaluate f of 2, you would have way too many answers. So remember that in order for something to be a function, for every input, there can only be one output. So you can't have this situation like this where basically all of the different y values go with the same x value. It just doesn't work the way that functions are supposed to work. So one more thing I want to mention about horizontal and vertical lines is their slope. So what is the slope of a horizontal line? Well, let's try to actually calculate it for this. So let's say we had a point here and a point here. I'll just pick 2 random points. So if we tried to calculate the slope, the vertical change would be 0, right? So if we tried to do the slope, we would get, let's actually plug in these 2 points. So this first point is the point 1, -3, and this second point is the point 3, -3. So if we did our rise, our vertical change, we would have -3 minus -3 divided by 3 minus 1. And so we would get 0 in the top, right? Through -3 minus -3 is -3 plus 3, which is 0 over 2. And so the slope would be 0. And so for any horizontal line, the slope is always going to be 0 because basically there is no vertical change, right? If you think about slope as representing the rise over the run, there is no rise. There's no vertical change. So what happens if we try to take the slope for a vertical line? So let's just pick 2 points here. Let's maybe say the point 2, 1 and the point 2, 3. So if we tried to calculate the slope here, we'd subtract our y coordinates. So let's do 3 minus 1. And then in the denominator, we'd subtract the x coordinates. So that's 2 minus 2. So we would get 2 over 0. Now remember that dividing by 0 gives you a result that is undefined. So for any vertical line, the slope is always going to be undefined. It basically just doesn't have a slope. And again, that kind of fits with the idea. It doesn't really go with these other things because it's not a function. It's a different kind of line. So yeah, I think that's another thing students sometimes mix up is the difference between the slope for vertical and horizontal lines. And if you just take a couple of points, you can easily see whether it's 0 or undefined. But another way of thinking about it, again, is just thinking about like slope as being how much is the graph kind of going up as you go from left to right? And so a horizontal line just isn't going up, whereas a vertical line kind of has something else going on. Because it's vertical, you basically just can't measure the slope. All right, so that is it for this video. Like I said, the next video we'll be getting into basically interpreting functions or linear functions in the context of word problems. And then in the next video, we'll be talking about point slope form, which is a different way of writing the equation of a line. So I'll see you all in the next one.